What is a primitive Pythagorean triple in geometry? Have you ever wondered what makes certain sets of numbers special in geometry? Today, we are going to talk about primitive Pythagorean triples. These are fascinating groups of three positive integers that fit perfectly into the Pythagorean theorem. The Pythagorean theorem states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. In mathematical terms, this is expressed as a squared plus b squared equals c squared. Here, a and b representing the legs of the triangle, while c is the hypotenuse. Now, a primitive Pythagorean triple is a specific kind of set of numbers. It consists of three integers, labeled a, b, and c, that satisfy the Pythagorean theorem. However, there is an important condition. These three numbers must not share any common divisor greater than 1. This means that the greatest common divisor of a b and c is exactly 1. In simpler terms, these numbers are coprime, meaning they cannot be reduced further by dividing them by the same integer. For example, the numbers 3, 4, and 5 from a primitive Pythagorean triple. They fit the equation 3 squared plus 4 squared equals 5 squared, and they do not share any common divisors other than 1. On the other hand, the numbers 6, 8, and 10 do not qualify as a primitive triple. They are simply multiples of the 3, 4, and 5 set, sharing a common divisor of 2. Primitive Pythagorean triples are essential because any Pythagorean triple can be created by scaling a unique primitive triple by a positive integer. This means that primitive triples are the building blocks for all right triangles with integer side lengths. To generate these primitive triples, you can use two positive integers, k and l, where k is greater than l. The formulas for a, b, and c are as follows. A equals k squared minus l squared, b equals 2 times k times l, and c equals k squared plus l squared. This method ensures that the triple is primitive if k and l are coprime and not both odd. From a geometric viewpoint, these triples correspond to right triangles with integer sides that cannot be simplified further. Understanding primitive Pythagorean triples helps in grasping key concepts about right triangles and integer relationships. They also have practical applications in various fields, including number theory, geometry proofs, and even computer graphics and architectural design, where right triangles with integer sides are relevant. So, the next time you think about right triangles, remember the role of primitive Pythagorean triples. They are not just numbers, they are fundamental to understanding the geometry of shapes involving right angles.